Okay. Then for this lesson, this top part, what I'd like you to do is just draw a pair of parallel lines with a transversal going through them. So there are my parallel lines, and then I'm going to draw a transversal going through them. We're going to review vocabulary first. And then I am going to label the angles. So I'm going to have angle equal, I'll label them and you can look up here to see how I'm labeling them. So we're going to start out with some identifying angle pairs first. I'm going to write off to the side here, corresponding. Somebody give me a pair of angles based on this picture that are corresponding angles. So from yesterday, Kylie? Not 1 and 7. Not 1 and 8, Spencer. 3 and 7 are corresponding. 1 and 5. 6 and 2, and 4 and 8. Okay, so there's always 4 pairs of corresponding angles. So again, corresponding, they're in the same position is how I think of it. So they're on the same side of the transversal, and then they're also kind of on the same side of their other line as well. So 1 and 5, 3 and 7, 2 and 6, 4 and 8. All right, what about, let's do alternate. I'm just going to abbreviate alternate exterior. So what's a pair of angles that are alternate exterior, Kai? 1 and 8. And then there's only one other pair, 2 and 7.
Holy. I know.
Okay, so alternate always means the opposite side of the transversal. And then exterior, they have to be outside of, on my diagram, it's the pink line. So the 2 and the 7, the 1 and the 8. What about alternate interior? What's a pair of angles that are alternate interior? Okay. 4 and 5. And then 3 and 6. Okay, so again, opposite sides of the transversal, the blue line on my picture, but inside of the pink lines, interior. So 4 and 5, 3 and 6. And the last one I'm going to have to write over here is the consecutive interior. So what's a pair of angles that are consecutive interior? 3 and 5. And what was the other pair? Nope. 4 and 6. So consecutive means they're on the same side of the transversal, the blue line on my picture, but again, they're interior, so 3 and 5, 4 and 6. Notice there's not a consecutive exterior, okay? So those are the special angle pairs we talked about yesterday. I guess I could do a better job of separating all of these here. And yesterday we looked at these angle pairs where the two lines, like my two pink lines, these would be parallel lines. So I need it quiet, please. Yesterday, these lines did not have to be parallel. We looked at these angle pairs, but these two lines did not have to be parallel. You just had two lines with a transversal going through them. Here we're looking at if those lines are parallel, what specific relationship do these pairs of angles have? This is thinking ahead. We're not doing proofs today, but it is thinking ahead to how they're used as reasons in proofs. And then we are using these relationships today. So starting with corresponding angles, abbreviation, if you don't want to write out corresponding angles every time, you can just write CA. Or if you see me write CA, corresponding angles. Corresponding angles, if the two lines are parallel, corresponding angles are always congruent. Okay, so each of these pairs of angles, 3 and 7, 1 and 5, 2 and 6, 4 and 8, if these lines are parallel, each of those pairs of angles are the same. Alternate interior angles, so you can abbreviate that AIA. Alternate interior angles are also always congruent when the lines are parallel. So the key here is I don't want you to miss out on this. This is if the lines are parallel specifically. So our alternate interior angles are 4 and 5 and 3 and 6 on our picture. 4 and 5 would be congruent. 3 and 6 are congruent to each other. Alternate exterior, so AEA, they are also always congruent. So in our diagram, in our picture, angles 1 and 8 are congruent and 2 and 7 are congruent to each other. And then consecutive interior angles, CIA. So these, and I know you should never go off of how a picture looks, but if you just look at angles 3 and 5, they don't look the same. They're not congruent, but they are supplementary. And supplementary means what? Yep, they add to 180 degrees. And then when we do proofs, this is how you would use them in a proof. Okay, so how this would be stated is you'd say if lines parallel, then I'm going to put CA for corresponding angles congruent. Okay, so not the best written sentence, but you actually have to write out a statement for the reason. It's not just by this property. It would be if lines are parallel, then corresponding angles are congruent, is how that reason would be used in a proof. So these are very similar. If lines parallel, then alternate interior angles, AIA, is congruent, or are congruent. If lines are parallel, then alternate exterior angles are congruent. And the last one, if lines are parallel, then corresponding interior angles, CIA, supplementary. Okay, so we're actually, again, not today, but eventually we'll be using these as reasons in a proof. So you would make a statement and then those would be your reasons. So if we look at, I know some of you might still be writing stuff down, that's fine, but questions 1 through 4 right below that, it says, are corresponding angles always congruent? Are alternate interior angles always congruent? Are alternate exterior angles always congruent? And are consecutive interior angles always supplementary? Would you say, based on what we just discussed both yesterday and now today, is this always true? No. When is it true? When the lines are parallel. So the response to all of these, only if lines are parallel. If the lines are not parallel, you still have those angle pairs, but the pairs of angles are not congruent or supplementary like they are if the lines are parallel. So you have to know the lines are parallel to begin with. Okay, so we're going to look at example 5. You're going to see different types of problems here. 5 gives us the measure of angle 11 is 62. This is information that applies to the whole thing, so I'm going to fill it in. Measure of angle 11 is 62. So this angle down here is 62. And the measure of angle 14 is 38. It says find the measures of all numbered angles. So we can actually fill in over here, 11 we were given is 62. 14 we were given is 38. How you are filling these in is you are using these relationships because notice here, these arrows, what do these arrows mean? These two lines are parallel. The other two lines would be transversals. Okay, so this is not only using, I guess, these relationships, but maybe other relationships that you know as well for angles. So for example, I'm going to find an angle. So you just kind of pick a place to start. I'm going to say, okay, just by looking at this, I know that the measure of angle 4 is also 62. Okay? Could somebody tell me why I know that? It's a corresponding angle to 11, and corresponding angles when lines are parallel are always congruent. Okay, so could somebody pick out what's another angle that you could find? Angle 3? Well, I heard. Ooh, yes, 3. So what would 3 be?
6.
But what's the measure of it? 62. Okay, 3 is also 62. Hold on, there's 2 reasons you could really give for that. Emma had said 3 and 4 are vertical angles. That's true, so they're congruent. Or what are 3 and 11? Alternate exterior, which are also congruent. So 2 different reasons why you could say 3 is 62. I heard somebody say they know 6. 6 is 38. Why is 6 38? How do we know that? Corresponding with 14. 9 is 38. Why? Vertical angle with 14. Eight is 62 as well. 8 is 62. How do we know? Vertical angle, okay. 12 is not 38. Twelve is, okay, hold on, quiet please. 12 is 118. Why? Yes, 11 and 12, or even 8 and 12 are a linear pair. They should, or they form a line, they add to 180. So 12 is 118. That means 7 is also, yes, 7 is also 118. What about 13? 142? Okay, hold on. So I got 13 was 142, supplementary here, or here. 1 you said was what? 38. Vertical angle with 6. So 6 and 1 should be the same. 10 is 142. 5, okay, hold on. I got 10 is 142. Faith, 5 is what? 80. And, okay, so how did we get 80 for 5? Okay, so we had, quiet please. Some of you see this, some of you may not. This is 62, this is 38. These 3 angles should add to 180. So if you subtract 62 and 38 from 180, you would get 5, which is 80 degrees. And then 2 is also 80 by vertical angles. Okay, so notice you're not only using the angle relationships that we are just discussing now, we are always still using vertical angles, linear pairs. Those are from chapter 1. You could use complementary angles if you have that in a problem. Okay, so let's go on. You'll also see problems like 6 and 7. Okay, so a similar idea is using angle relationships that you know, whether it again is from the last 2 days or if it's still like a linear pair, they're supplementary or they're vertical angles, they should be congruent. But you're finding the missing variables, x and y. So if we look at 6, and it doesn't matter, it's not saying which one you have to find first, but what you should notice, these 2 lines are parallel to each other. Did you see that? So what did you say? Y is 114 degrees. How do we know that? It is a corresponding angle. These are corresponding. They're the same. So we know Y is 114. Then, I could actually write that in. I know this is 114. X, okay. You got what? Okay, and how'd you get that? Okay, so these 2 angles here, these 2 should add to 180. So I'm gonna set up an equation. Kai described it correctly, but I'd have this angle is x plus 12 plus this angle is 114, and that should equal 180. Okay, so then I could solve this equation to find x. So Kai had done the subtracting the 114 and subtracting the 12. You could also, if you set it up this way, combine these. So you'd have x plus 1 126 equals 180. And then if I subtract 126, I should get 54 for x. Okay, so corresponding angles and then angles that are a linear pair. They should be supplementary. 7, the diagram for 7 is a little weird. At least I think it is. Okay, so here I do want to show you one thing you could do when you have a picture like 7. Because I do see, I need your attention please, I do see parallel lines here, or parallel segments. What you can do is you could extend them. Okay, so I could extend, these are my parallel lines, and that means this here is a transversal and this is a transversal. So you can extend it so that it looks a little bit more like what we had drawn at the very beginning. And you can see where we have y and where we have x. This one, there isn't one that you have to find first. Like in number 6, we needed to know y first to be able to find x. Here you could find either one first. So let's actually start with x. Anyone know how we could find x? By looking at that picture. So, okay. What did you say, Lily? Okay, why? Yes, these are alternate interior angles. So they are congruent. Okay, so you can set them equal to each other, and then we can divide by 2 to solve for x. So x should be 54. Okay, so now what about to find y? Well, so I could plug x in. I know this whole angle is 108. I actually don't need that angle to find y though. Well, these two angles don't have to add to 180 because these two lines are not parallel. These ones are. Wait, say that again. Yep, but these are not the same. Oh, these lines are not. No, these two angles do not have to add to 180. For the same reason, these two lines are not parallel. Okay, I hear, guys, there's a lot of conversation happening that's not about this. I'm looking for how, with what I have, what do I have to do to find y? Keep in mind, as you're looking at this, these two lines are your parallel lines. Does it help if I cover this up because you don't need any of that? So what do I know about the 5y and the 120? Consecutive interior. So what does that mean? They're not congruent. They equal 180. They're supplementary. So 5y plus 120 should equal 180. These two together should equal 180. Okay, and then if I solve this, so if I subtract 120, so 5y equals 60, divide by 5, so y is 12. There's my y. Okay, I want to give you time to work on your assignment. So here's the plan. We are going to discuss this question tomorrow because this is still a good question. So we'll discuss this one tomorrow, but I do want to pass out your assignments, give time to work on that.
What happened?